So we're going to look at multiplying when we've got some negative numbers. We'll look at a couple of examples to make sure we understand. Well, 2 multiplied by 3, you're probably all right with doing without anything else, but I'm just going to show you the method and then we can use it for negatives too. So 2 multiplied by 3 would be 2, and you've got 3 lots of it. 1, 2, 3. So that would be 3 lots of 2, or you could do it as 2 lots of 3. You could even do it as an array like that, like a rectangle. So you've got 2 lots of 3, or because multiplication is commutative, that's also the same as 3 lots of 2. Okay, so that's the same as 3 lots of 2. And we can clearly see that we've got 6 boxes there, so that is 6. And it's positive 6 because each of the boxes is the positive side. What if, though, instead I had 2 lots of negative 3? So I need 2 lots of negative 3, 2 times negative 3. So that's negative 3, if we remember from these. And that's 1 lot of it, so I need another lot of it, and I'll put it underneath here. And we can see that is negative 6. And because multiplication is commutative, we also know that's the same as negative 3 multiplied by 2. Remembering this 2 is positive each time, but because positive is implied, it's the default, we don't bother write it, so it's just 2 times negative 3, or negative 3 multiplied by positive 2. So that's interesting. If we multiply 2 positives, we seem to get a positive. If we multiply a positive and a negative, we seem to get a negative. All right, let's see what happens if I multiply 2 negatives. What happens if I was to multiply negative 2 multiplied by negative 3? Well, that's a bit tricky. I can do the negative 3. That's 1 lot of negative 3. And we already know 2 lots of negative 3 looks like this. But what does negative 2 lots of negative 3 look like? Because it doesn't look like this. This is 2 lots. This is positive 2 lots. Well, to make individual tiles negative, I have to flip them over. So I know that 2 times negative 3 here is negative 6. But I'm flipping every tile over because I want negative 2 times negative 3. So if I flipped each of these tiles over, this is what I'd get. So I'd actually get still 6, but this time it's actually positive 6. This is positive 6 or just 6, it doesn't matter. So that must mean that negative 3 times negative 2 is also positive 6 or just 6. It's the same. Okay. So we've noticed, and so that if you multiply 2 negatives, you seem to get a positive. And as with many parts of maths, there are rules that we can learn with these, and the key rule is this. When we multiply or divide, negative signs always come in pairs. It's like they've got a partner and they can't be separated from them. So let's just check if this works with the ones we've done before. So first of all, 3 times 2, well, there was no negative signs there. So there's no negative signs in the answer. There's nothing. That's fine. Here, we had a negative sign here, but none here. So it only had 1, so it needed to have a pair. So it had its pair here. So now we've got a pair of negative signs. That's good. And here, we already had a pair of negative signs, so we didn't need another one. So it was positive. So negative signs always come in pairs. There's always got to be 2 of them, or you could have 4 of them. For example, I'm going to look at one last example before we finish. If I had negative 2 multiplied by negative 5 multiplied by negative 10, okay, well, let's think first. Is my answer going to be positive or negative? Well, I've got 1 negative and another one. That's a pair. That's fine. And 1, this one can't be on its own. We don't get single negatives, so I must have another one in the answer to make sure there's an even number of pairs of negatives, and then I can just do the integer multiplication. 2 times 5, 10 times 10 is 100. So my answer is negative 100. Have a go at the drill.